Okay, and so today on circles, we are going to look at tangents to circles. So finding the equation of a tangent or tangents to circles. Okay, so we'll just very quickly go through this one. We've seen this kind of question before, but just to keep everything together. So this asks us find the equation of the tangent to the circle at the point here. So the first step that we're always going to do is to do a little sketch of the circle. In all these kind of questions, that's the first thing we should do. So we're given the equation of the circle. So let's straight away work out with what's the center and what is the radius. So here we have it of the form x squared plus y squared minus 2gx minus 2fy plus c equal to 0. So we know there that the circle or that the center is equal to, well, half minus half of the x value. So that's going to be minus by minus is a plus. So that is 1 comma and half minus half of the coefficient of the y is minus 2. So that's our center. We know our radius is equal to the square root of g squared plus f squared minus c. So r is equal to the square root, and that's minus g minus f. So minus 1 to be squared plus 2 squared minus 20, and that's the square root. So r is equal to the square root of 25, which is 5. Okay, now we actually even didn't have to work out the radius, because we could just draw our center and then put our compass to this point here, which would give us the outline of the circle. But anyway, we've that bit done, so let's sketch our circle. Okay, so there's a rough sketch of our circle. We know that the tangent is at, or goes through the point, or is at the point minus 2 comma 2. So if we just sketch in that point as well, that will be minus 2 comma 2, so just around there. Okay, so we can draw our tangent line through it, through the point there now. Just again so that we have a rough sketch. So something like this probably. Okay, it doesn't have to be very accurate. I'll just do it in the pencil feature. Okay, so that might be something along the lines of our tangent line. Okay, and just the last thing, just before we move on, what's really important is we know that always our tangent line is going to be perpendicular to our radius line. So our next step is always to find the slope of our radius and then use the perpendicular slope through this point here into the equation of the line formula will give us the equation of the tangent. So let's just write that down as our second step. Okay, so there's our steps written down. So make sure and let's get those steps written down also before we start into the question. So they can go over here with these steps. So that's the 4 steps together to solve this question. Okay, so to start us off then, we have the point is minus 2 comma 2. Our center is 1 comma minus 2, so we're going to get the slope of that line. So we've x1, y1, x2, y2, and so m is going to be equal to y2, so minus 2 minus 2 all over 1 minus 2, which is equal to minus 4 over 1 plus 2 is 3. And so that's the slope of our radius, or we can call it, which means the perpendicular slope is equal to 3 over 4. And that's the slope that's really important for us for our equation of the line of the tangent. And so we're just subbing into that. So we have y minus, well, y1 is, and again, really important that it's this point here that we're using the 2 minus 2 comma 2. So, and that's what we've called x1, y1 in this case. But just in case we haven't done that the first time around, let's write them out and label them again. So we'll have minus 2, comma 2, and that's x1, y1, and we can just put those up neatly here beside our slope. So here we're going to have y minus y1, so y minus 2 is equal to m, which is 3/4 bracket x minus minus 2, which is x plus 2. So here we've got 4 times y minus 2 is equal to 3x plus 2. And just finishing off, tidying it up and bringing everything over to one side. That's going to give us 3x minus 4y plus 6 plus 8 plus 14 is equal to 0. Okay, and that's our equation of the line. Just the last thing to note before we move on, our slope here was positive, and as is the slope of this line. As we can see, it's moving uphill. So that's our equation of our tangent. So now let's look at an example where we find the equation of tangents from a point outside the circle. Okay, so we see here in this question, find the equations of the tangents from this point here to the circle, x squared plus y squared minus 12x minus 10y plus 51 equal to 0. So again, the very first thing we're going to do is to sketch this circle. So we'll work out our radius and our centre from obviously the formula, or we can see that it's of the form x squared plus y squared minus 2gx minus 2fy plus c. So using our formula in the log tables, let's work out the centre and radius of the circle and then do a little sketch. Okay, so here we have our centre, we have our radius. We see our radius is the square root of 10. So this time we'll be doing a rough sketch with a radius of 3.1 or 3.2. And obviously then also sketching the point here. And so that will give us a rough idea of what we're looking at. Okay, and so here is a sketch of our circle with the point outside it, just to mark in the centre of it. Okay, so and then our next step is to draw a rough sketch of two tangent lines to the circle that go through this point here, because we don't know if the tangent could be that tangent that we're asked for, or that it could be this one up here. Okay, so these don't need to be totally accurate or anything like that. It's just to give us a guideline of what we would be working with. Okay, so here basically we can see that we would have both of our slopes we would expect to be positive then in this instance. Okay, so here is a list of our steps from the previous question. So we've done the first one, we have sketched the circle. The next step says to find the slope of the radius to the point. But obviously we don't have a point of where the tangent touches the circle this time. So instead of finding the slope of the radius, we're just going to use a slope and we're going to call that slope m. So we're going to form an equation of a line using just the letter m in this instance. That's our formula there. We're going to have m is going to equal to m. And the point that it goes through, the one thing that is for certain, the tangents both go through the point 1, 0. So that's going to be the point that we use, the point that we're given in the question. So that's going to be x1, y1. So our equation of our line is going to be y minus 0 is equal to m bracket x minus 1. And so tidying that up, we have y is equal to mx minus m, and tidying it up just even further, that gives us mx minus y minus m is equal to 0. And so we have an equation that is of the form ax by c equal to 0. Okay, and that's going to be important for us. So we're going to put a red box around that for the minute. So our next step is that we want to solve for m to give us our possible equations of the tangents. So the only other thing that we do know, so what we do know is that obviously any time that we have a tangent line, that the perpendicular distance from it to the centre of the circle is equal to the radius. And at the very beginning, we also got the radius here. So we can use our perpendicular distance formula to solve for m, giving us our two equations of our tangents. Okay, so subbing into our formula now, we have, so I'm just going to label here, we have a, b is minus 1, and c is going to be minus m. And it's obviously our distance from these equations to the centre, so we're using the centre as our x1, y1. Okay, and so that's what we're going to sub into. So here we have m bracket 6 plus b, which is in this case minus 1 bracket 5, plus c, which in this case is minus m, so it's the absolute value of this all over a squared, so m squared, plus b squared, which is plus minus 1 to b squared, the square root of that, and all of that is equal to our radius, which we worked out to be the square root of 10. Okay, and so tidying up then, that gives us 6m minus m, so 5m minus 5, and that's the absolute value of that, and we're just going to have by the square root of 10 times the square root of m squared plus 1. And so just to tidy this up, make it easier for ourselves, get rid of the absolute value signs, we are going to square both sides. So when we square both sides, that gives us 5 5s, so 25 m squared minus 50m plus 25 is equal to 10 m squared plus 10. And so tidying that up, that's going to give us 15m squared minus 50m plus 15 equal to 0. And so I'll divide across by 5 to reduce that down, which gives us 3m squared minus 10m plus 3 equal to 0. And so in brackets then we're going to have 3m and m and 3m times 3 and m times 1. That gives us 1m and 9m, which gives us 10m, so they're both going to be minus there. So that means putting both of those equal to 0. We have 3m is equal to 1, so m is equal to a third. And here we have m equal to 3. And so they are what we are going to sub back in to our original equation that we formed. And our original equation is here as mx minus y minus m equal to 0. So we'll take our first one, which is m equal to 1/3, which gives us 1/3 x minus y minus 1/3 equal to 0. So I'm just going to multiply across by 3 to make that easier. So that gives us x minus 3y minus 1 equal to 0. So that's one possible equation of the tangent to the circle. And then the last one, we have m equal to 3. So that's going to give us 3x minus y minus 3 equal to 0. And so that's our two equations for the two possible tangents from this point here, the point 1, 0, to the circle. Okay? Okay, so we've another similar question here to find the equation of a tangent to a circle, and at this time the tangent is parallel to a given line. So first things first, we'll write down our centre, our radius, and sketch the circle as we always do. Okay, and so we can see that our centre is minus and half of 6 is minus 3, minus and half of 2 is minus 1, and our radius then is equal to 5. So let's just sketch quickly the circle. Okay, so here we have a sketch of our circle. We've noted in the centre point, and then I've just sketched in the line that we've been given. Now, what we can see here is obviously that line intersects the circle, so it's not going to be a tangent to it. However, we know that the tangent is parallel to this line. So if I move forward like that, then a tangent might be there. And similarly, if I go down here, parallel to the line, we might have another tangent here. So both of those lines, the equation of the line is essentially the same, because obviously if a line is parallel to it, it has the same slope. What does change, here this line crosses at minus 2.5, whereas if I go parallel to it, the line crosses at 3, for example. So, and here again, parallel to this line, the line that is tangent to it crosses maybe further down off our graph. Okay, so what will change then is the format, or what changes here is this part of our line. So we'll have our 3x plus 4y, but this value here is going to change. So very similarly to what we have done before, we have our equation of our line. So a, b, and here is c. We know it's going to be the perpendicular distance from it to the center of the circle, to x1, y1 here, is going to be equal to the radius. So again, just using our perpendicular distance formula, this time we will solve for c. So I'm just labeling this up here as x1, y1. So this time we have 3 bracket minus 3 plus 4 bracket minus 1 plus c, and that's an absolute value, all over the square root of a squared plus b squared, which is 3 squared plus 4 squared, the square root of that, and that's all going to be equal to 5, which was our radius up here. Okay, and so now we're just going to solve away here, which means up here we have, well, 3 by 3 is minus 9, minus 4, so that's minus 13 plus c, which is c minus 13, all over the square root of 25, which is 5, and 5 times 5 over here is 25. So just multiplying that bit there was equal to 5, so cross multiplying. Okay, so now in order to get or to solve for c, well, we know this is the absolute value. So that means that I have one version is the positive version, c minus 3 is equal to, c minus 13 is equal to 25, and the other option is c minus 13 is equal to minus 25. So here we're going to have plus 13, here plus 13, and they cancel. So here we have c is equal to 38, and the other option here, they cancel, and we get c is equal to minus 25 plus 13 is minus 12. So there are two values for c, which means we can now go back to our equation of our line and substitute in, and we have the two equations of the tangents to this circle that are parallel to this line, and they are 3x plus 4y plus 38 equal to 0, and 3x plus 4y minus 12 equal to 0. So there's both the equations of the lines of the two tangents parallel to the line that we were given in the question. Okay, so let's get these examples taken down.